Hello students. Today I am going to discuss a very important topic, factorization. This topic you already studied in your earlier classes in class 8th and ninth, but so many students uh, don't understand the concept of this factorization, and they always confused. That's why I am going to make a lecture video on this topic. So recall some identities. The identity first is a plus b whole square equals a square plus 2ab plus b square. Second one is a minus b whole square. This is a square minus 2ab plus b square. Third identity is a square minus b square, that is in bracket a plus b, a minus b. And fourth one is x plus a into x plus b equal x square plus a plus b times x plus ab. So this four identity you can simply use to factorize some special type of problems. But if any expression uh, or polynomial has a form that fits the right hand side of one of these identities, this means if a polynomial or expression is given to you, then you have to check that which of these identities is applied on the expression, and then corresponding left part gives you a factor of that expression or polynomial. So the following solved example I am illustrating here so you can simply understand the concepts. For example, so factorize x square plus 8x plus 16. Observe the expression, its first and third term, that is x square and 16, are complete square terms. So from our first identity you can see right hand side a square plus 2ab plus b square. You can arrange our given example in the form of this first identity. Look at the last third line of the slide. A square plus 2ab plus b square equal x square plus 2 times x times 4 plus 4 square. So in this identity x is working for a and 4 is working for b. So simply our polynomial x square plus 8x plus 60 is arranged in the form of our first identity. So applying first identity, we can see a plus b whole square, that is x plus 4 whole square. These are the required factors of our polynomial. So many cases where you can apply this identity, but there are many cases in which these identities do not work. So I am going to give some example for that later, but before going to this, take one more example. So look at this example here. Factorize 4y square minus 12y plus 9. Here you can clearly see 4y square is nothing but complete square of 2y, and third term 9 is nothing but it is square of 3. And look at the middle term. Since middle term has a negative sign, that's why I am going to apply second identity here, that is a square minus 2ab plus b square. So here uh, 2y is working for a and 3 is working for b. That's why by identity 2 it is square of a minus b whole square, and since 2y is working for a and 3 is working for b, therefore our factors are 2y minus 3 and 2y minus 3. So similarly you can see example, second one example, that is 49p square minus 36. So 49p square is nothing but 7p whole square, and 36 is nothing but 6 whole square. So I am going to apply here identity third, which is a square minus b square. You can see in previous one slide our third identity a square minus b square, which is a plus b a minus b. That's why in this example 49p square minus 36 implies 7p whole square minus 6 square. By identity 3, this will give you 7p minus 6, 7p plus 6. Now I am going to discuss fourth type of identity for factorization. So factors of the form x plus a and x plus b. Look at the above expression, x square plus 5x plus 6, y square minus 4y minus 12. In given to expression, you can clearly see that third terms 6 and 12 are not complete square. That's why we can not apply first, second and third identity, that are a minus b whole square, a plus b whole square and a square minus b square, because these are not perfect square terms. So in this case we may use identity x plus a and x plus b, that is our identity for x plus a x plus b equal x square plus a plus b times x plus ab. So in example you can see, factorize x square plus 5x plus 6. When you compare this identity with the right hand, with this expression with the identity 4, look at the right hand side, x square plus a plus b times x plus ab. You can see a plus b is factor of, is coefficient of x, and in our problem 5 is coefficient of x, and in our identity a into b is constant term, and in our example constant term is 6. So by comparing the identity with the given example, you can check a plus b equals to 5 and a into b equals to 6. So this method is also called middle term split method. So here we want to find two integers a and b such that they satisfy equation 1 and equation 2 both. So in order to decide which values of a and b you have to take, look at the factors of a into b, that is of 6. So here are the factors 2, 3, 6 and 1 of 6. 2, 3, 6 and 1 are nothing but the factors of 6. So you have to take pair of two integers, either 2 or 3 or 6 or 1. So you can clearly see 2 and 3 satisfies both the equation, that is 2 plus 3 equals to 5 and 2 into 3 equals to 6. But and 1 is not possible, because on taking 6 and 1, equation 1 gives 6 plus 1 7, but we don't need 7, we need a plus b equals to 5. That's why a equals to 2 and b equals to 3 are our value for a and b. So by identity 4 you can see x square plus a plus b times x plus ab, that is right hand side of our identity 4 has factor x plus a and x plus b. That's why our polynomial x square plus 5x plus 6 gives the factor x plus 2 x plus 3, where a equals to 2 and b equals to 3. So you can understand this in second last line of our slide, x square plus 5x plus 6. When you arrange a equals to 2 and b equals to 3, these two values in our identity 4, this will give you x square plus 2 plus 3 times x plus 2 times 3. So required factors are x plus 2 and x plus 3. And one more example, we can take the main thing that you have to notice in this example, that x square has coefficient 1. Now I am going to give you an example in which x square has coefficient other than 1. So look at the example here. Our expression is 2x square plus 5x minus 3. Coefficient of x square is 2. So we have to compare carefully. So when we compare this with equation 4, with our identity 4, a plus b equal 5 and a into b equals to 2 into minus 3, that is minus 6. Here one thing that you have to remember, whenever coefficient of x square is not 1, then you need to multiply constant term with the coefficient of x square. So now we want to find two integers a and b satisfying equation 1 and 2. So look at the factors of a into b, that is of 6. 6 has factor 2, 3, 6 and 1. So we have to take one of the pair, either 2 comma 3 or 6 comma 1. So here 2 comma 3 not satisfy both one of the equation, that is of equation 2, because when we multiply 2 into 3, this will give you 6, but we need uh, a into b equals to minus 6. That's why I am taking a equals to 6 and b equals to minus 1. So when we take a equals to 6 and b equals to minus 1, both the equation will satisfy the values. 6 plus 1, 6 plus minus 1, that is 5, and 6 into minus 1 gives you minus 6. So 2x square plus 5x minus 3, I am arranging the terms, splitting the middle term 5x as 6x plus minus 1x, and in a second step I am writing minus 3 as minus 1 times 3. So I can take common values easily. In first two terms you can see 2x is common, then on taking 2x common, there is in bracket x plus 3, and last two terms you can take minus 1 common, so in bracket you can see value x plus 3. So second last step, you can check x plus 3 is common in both the terms, so taking x plus 3 out, remaining term you can write in bracket 2x minus 1. Hence x plus 3 and 2x minus 1 are the required factor. If so, I need to make this video on factorization because so many students do not have proper knowledge of factorization, and before going to make my next video on chapter 2 polynomial, I need to give you some basic knowledge of factorization so that you can understand the chapter 2 polynomial clearly. So I hope you understand the concept, this concept of factorization. So thank you for watching. Like and subscribe my YouTube channel. Here is the link in description. Thank you.